Okay, now we will move to the next method, which is method of exactness and integrating factor. So we look first to the method of exactness. Okay, for this example, okay, let's look to the equation. The equation is 2xy dx plus x square minus 1 dy equals to 0. So for this method, I need to separate it for m and n. So for m, I put it for 2xy, and for n, x square minus 1. Okay, how I want to determine which one is m and n. For me, for the example one, for m, I just take the 2xy because it dx. So m, I take it for dx, and n dy. So just put the equation, and for the method of exactness, we need to determine first whether it is exact or not. So the m, we differentiate m to the respect of y, and n to the respect of x. Usually we differentiate x first, right? But this one we differentiate y first, so we will get both 2x. That is mean when both are 2x, that is mean the function are exact. When are exact, we can proceed to the next technique. So we differentiate again. We determine this delta f over delta x equals to msy. So for this one, we need to integrate, like just take this one dx to sy dx. For this method, we want to show and to determine whether it is exact or not. But next we integrate this. So usually after we integrate a function, we will equals to c, but this one we change it to hy because this is the method of exactness. Next we just put it back the method, this method, this example, I'm sorry, this answer, n equals to the function of n. Okay, so when after that we will integrate h prime y, which is we have already differentiate this one, and we integrate it back, so we will get negative 1 dy. So to determine the hy, because the hy is equals to c actually, then we will get the answer x square y minus y. Okay, let's move to the example for integrating factor. Okay, we look for the equation first, which is 2y minus 4x squared dx plus x dy equals to 0. For the integrating factor, okay, for this one, I want to look it, so I expand 2, I just multiply with the equation in the brackets. So after I expand, it will look like this, and I put the x dy to the other sides. Okay, after that, we want to look it more easier. We use the separation of variable, and we will get 2y over dx. So it will looks like this: 2y minus 8x squared over x. Then we make it more easier with dy over x and negative 8x squared over x. I don't write it to make it simple, so it will just looks like this. So 8x squared over x already has potong and potong. It will become 8x, and we bring it to this side, and it will positive, and we equal it to 0. Okay, so we will get, after we get this type of equation, then we can proceed to integrating factor. So for integrating factor, we integrate exponent of integrating factor 2 over x dx, and as I said, 2 over 1 over integrating 1 over x, we will get ln x. So after that we will get e exponent to the power of 2 ln x. Then as we can then it will, after that it will become x square, because it is ln made with exponent, it will cancel each other. But for this one we use the log. So log, it will not directly looks like 2x, but the x with x square, because 2 is the constant, will be x square, will be the power. Then okay, for integrating factor, any method of integrating factor, after we get this, we need to multiply x square to the both sides, to the equation back. So we multiply x square, and we will get like this: x square y equals to x cube. Then we will integrate, and we will get the answer. Integrate x cube, and the answer is 2x power of 4 plus c. Okay, the other method, like this one, actually at the first place I don't understand why I need to multiply with x square, but now I have understand it. Like anything I got from this one, from the exponents, I will multiply it, the not only x square, but it can be many answer, many things to multiply, such as 1 over x. I thought it is for x square only, but I am wrong. Okay, so I have know it now. So I hope I can say this in the exams, inshallah. Okay, for the next method, I will explain it in the other videos.